Interface engines. As a PACS administrator, risk administrator, radiology informatics professional, you probably won't have access to the interface engine, but all of your messages go through the interface engine, so being good friends with your local interface engineer is a good thing to be. So, I asked an interface engineer friend of mine to put together a PowerPoint about interface engines and what he would want radiology informatics professionals to know about interface engines, and this is what he came up with. A HL7 interface engine is an interface or integration engine built specifically for the healthcare industry. It connects legacy systems by using a standard messaging protocol, HL7. Because hospitals and other healthcare providers usually have different systems for different aspects of services, they're often unable to communicate with each other. HL7 gets around that problem by providing the framework for the exchange, integration, sharing, and retrieval of electronic health information. These standards are the most commonly used throughout the world. An interface engine or integration engine is middleware built specifically to connect systems. The engine eliminates the need for individual connections between systems and orchestrates the message workflow, transforms message formats as needed, and guarantees message delivery. Integration engines go one step further than interface engines and simplify system interoperability by enabling workflow, not simply message orchestration. So we'll talk a little bit about the difference between interface and integrate in a moment. Interface engine benefits. Point-to-point interfaces are sufficient to get you going or for getting your feet wet. After all, they don't require major time or financial investment. However, as soon as you need more than a handful of interfaces, complexity and costs increase exponentially. That's when it becomes more cost-effective to start working with an engine. Again, you may find you simply need plain vanilla interface engine. But if your data exchange needs are more complex, in other words, they're dependent on clinical workflows involving multiple systems or multiple locations, you probably want to consider a more sophisticated integration engine. While you won't get away from the complexity with interface and integration engines, you will find they are more cost effective for dealing with more complex environments. So here's a slide that kind of explains what he's trying to tell you there. So in this top box, right, going this way you have the cost of the system, and this way you have the complexity. So if you do point-to-point interfaces, right, not very complex, pretty easy to do, but they get costly pretty quickly. So if you do interfacing, all your systems interface through an interface engine, and we're talking about all the systems in a hospital, well, it's low cost, and then it gets further and further down the complexity axis. So it starts out with a very low cost, gets more complex. Integration, where systems have their own engine inside of them. For example, let's talk about Epic for a minute. Epic is a hospital information system that inside that has its own radiology module. It has its own cardiology module. It has its own billing module. So instead of interfacing three of those systems together, they're all integrated inside the Epic system. The Epic still uses an interface platform called Bridges to move the data between those modules, but it's not going outside the Epic system. That's an integration solution, and it has a high startup cost, but it stays relatively flat in terms of cost. You can see point-to-point and interfacing quickly exceed the cost of an integration. It stays pretty flat, and it does get quite complex. So, depending on how many systems you have and what you need to do, obviously a standalone system would need no interfaces. If it only has maybe one connection, you could do it with a point-to-point. If it has two connections, you might want to go with an interface. And so this might be something like your voice recognition system. The voice recognition system may need to talk to PACS and RIS, but beyond that, it doesn't need to talk to the hospital information system or the billing system. It just needs a couple of connections. Once you start getting to a point where you have 3, 4, 5, 6, 8 connections, you want to start looking at integration capabilities and full interoperability, where you may need to use vendors like Epic that have an integration engine built into them, or continue to do the interfaces through your own interface engine at your hospital. So, how do they work? HL7 suggests message structure doesn't suggests message structure but doesn't specify how to transport those messages. It just says this is how you make this the structure of the message, but it doesn't tell you anything about how to get that message from one point to another. It's the role of the integration engine to translate, mediate, orchestrate, and route messages. Each interface uses the transport mechanism, making the most sense based on the system requirements and limitations. So it may be TCP sockets, file transfer protocol, FTP, web services, email, to name a few. Each system will use its favorite transport protocol, data exchange protocol. That's why you need a translator to convert the message to a format each system will understand. Let's stop there. So, inside your integration or interface engine is a translator. It takes the HL7 message, looks at the fields coming out of RIS, and it will repopulate that into a different message as it goes out to the PACS system. Okay? Some of those fields will need to be translated into different other fields between two systems if they don't match up perfectly. Okay? Now the required fields will obviously match up perfectly because they're the required fields. But when you get into the optional fields, maybe I want the patient's religion in the PID segment and maybe the PACS needs it in the ORC segment. So that's a translation that gets done by the interface engine. You can build the translator into a point-to-point interface, or if you're using an interface integration engine, make sure it includes a translator. All engines do at this point. Fortunately, interface and integration engines handle message transformation between systems. In other words, they can pick up a message in a certain format and create a new message in a new format while retaining the same meaning across both messages. However, interface and integration engines stand apart in how they move data. While a typical interface engine moves information from point A to point B using a hub and spoke model, an integration engine taps into business workflows to transfer information. In other words, compared to an interface engine, an integration engine provides more flexibility and control and visibility over data semantics. Here are some common interface engines: Orion Health Rhapsody, Siemens OpenLink, which a lot of people sometimes call Broken Link because it doesn't work very well, Sun eGate, and Epix Bridges. Interface engines don't fix bad data. Okay, you can really tell this was written by an interface engineer now. The real issue is with data formats, workflows, and meaning, and interface and integration engines don't address these problems. What he's trying to say there is, hey, we just get the data from one system and we translate it into the format it needs to be in the outgoing system. You know, we don't fix bad data. We just move the data from one point to another. It's quite common for two or more departments, and by extension the systems they use within the same hospital, to use different definitions and data structures to indicate the same information. Consider this example. A physician adds a note, NA, meaning not applicable, to a patient's chart indicating that information was never gathered about allergies to medications. Later on, another physician looks at the patient file, interprets the NA code as no allergies, and orders an antibiotic drug. The patient dies from allergic reaction. While this is an extreme case, it's well within the realm of possibilities. And this is why the meaning, the semantics of data is everything. So the real challenge is at the information level. What information is needed by whom, when, and in what format. Once you have these answers, you need to validate that information is being transferred using the same semantics. So, what he's trying to tell us is it's really up to us, the RIS system administrator, the PACS system administrator, the lab system administrator, the pharmacy system administrator, the medication administration record administrator, to work out these semantics and make sure our data lines up, because the guy running the engine in the middle, he just sees NA. He doesn't know what it means. He doesn't have the context of what that NA means in a particular field. It's up to us at the ends of the transaction to make sure our data lines up. So, 6 questions to help your team understand healthcare data. This is what he wants us to know. Understand the message interface specification provided by your vendor. If I just tell my interface guy we use HL7 2.4, that's not enough. Ask the vendor to provide details about messages, segments, fields, and the need for Z segments. Anytime you have data that doesn't fit into a particular segment, you can create a miscellaneous segment called a Z segment because it always starts with the letter Z. Understand the type of message that will be generated based on the event. a patient admission, patient visit, canceling a transfer, sending a partial lab result, understand what data is provided within the event, including the various code sets. Again, understand your event codes. That's what's important in number 2. Number 3, how do the code sets and content evolve over time, and who handles updates and how? Right? If you change the code sets in a particular message, you need to communicate that to your interface engine engineer so that he can update his set of codes in the translation table. Where does the data go? Is there a need to protect sensitive data? Again, it's not up to him to make sure that PID 10 is being blanked out. If you're sending something out of the country and you need to block out PID 10, it's up to you to do it. The interface engineer is not going to know to do that. How does the new system manage errors? What happens to messages that aren't understood by the destination system? What happens to rejected messages? Do you monitor your logs for rejected messages? You know, you don't want the patient to sit there for 2 hours and then discover that the order message didn't get received. That's not good patient care. And lastly, he wants us to know how we would handle workflow changes. If there's a matter of adapting the interface, how is this handled? How long does it take? How much does it cost? And who pays? So if your workflow around a patient change and you need to send different messages, you know, you have to get the interface engineer involved, you have to do a translation table, and somebody has to pay for his work. So maybe the radiology department has to pay for his work, maybe the lab has to pay for his work. If we both want to do it, maybe we split the cost, things like that. So this one ran kind of long, I'm sorry. So hopefully you got some good information about interface engines out of that. Thank you for watching.